Hello everyone, welcome to this video. In this video, we are going to do 5 questions on while loop. So we might do in a single video or we might break this video in 2 parts, but there will be 5 questions that I'm going to show you how you to actually solve while loop questions, build the intuition before coding. So whenever you hear a question, don't just start coding yourself, right? You have to build an intuition in mind that, okay, what is the architecture of this, how this thing will eventually work around. Okay, so that you need to think around, and after that we will solve the question. So it's going to be long video. I will try to break it in 2 parts, right? But there will be 5 questions, so just try to understand how I am solving the questions. Whenever I hear something, I don't just jump in. I create a logic first, then I put that into code. So let us say we have before that, let's understand one basic concept of Python, that when we have to print strings, I didn't talk about, because this is not a concept that I take a class on it, but this is just a mini concept, I will say. For example, let's open a Python workbook. For example, I want user to give me a number. For example, let's say a user has given me a number n equal to 10. Okay, I want to print a line that the user has given the number 10, for example. Now I want to keep on varying this, because if n changes, I want that this print automatically changes. Right now what happens, for example, right now if I just do a print like this, okay, what will happen that it will only print 10. Just a second. So it will only print 10. Okay, now if I change n to 20, I want that this line gets updated. So how do we do that? For that, there is a concept of f string literal. So it is called f string literal. So f string literal. So what does it mean? It just means that f means formatted string. So what you do is that whenever you write something, for example, let's say you have to create a variable. Let's say created a variable num equal to something. Let's say this varies. For example, let's say right now it is 5. So what you do print, okay, whatever the text part that you have to print. So first of all, you will write down an f keyword in front of this, and you will start a inverted quote. Okay, now whatever the text part that you want to write it down, you write it. For example, the number is, okay, this part is constant in everything, and the variable part, that is the num value, you keep in curly braces. Okay, and in curly braces you just write the variable name, for example num, and you just keep on printing. So whenever your num changes, this line will change. So let's go back to the code once again. Let me explain you. So what I'm saying is that so let's say the user, so how will we write down the f string literal? It is called print. Now f will write the keyword, okay, the user, or we'll say the user has given the number. So this part is constant, because this will remain constant in all of the prints, right? So we are not changing this, but whatever the part that will change, we have to put them in a curly braces, and then we have to close down the f string literal, and then we have to close the bracket. Now inside the curly braces, I need to pass n. Okay, so this is how it is done. Now if I print this, the user is given number 20. Now if I automatically change it 30, okay, so it will become 30. So I don't need to write a print command again and again for this. This is also a part of like dynamic coding, where you provide, you change the value just at the variable level, and all the print commands will be updated. So remember this f string literal, how to print it. So this is one of the numbers. Now let's say, so we'll use this concept ahead, when we are using for like this example. Now let's come back to our question that we have for the first question that we have for today. Okay, so the first question that we have for today is count the number of for example, so the question that we are going to solve at first of all, it is count the number of digits in a number. For example, let's say a user provides any number. For example, let's say a user provides the number 432. So how many digits are there? There are 1, 2, 3 digits. Okay, let's say user provide 10001. There are 5 digits. Okay, so we have to build a while loop, or basically that how do we print this. So let's understand the intuition first. First of all, how this thing actually works. So let's see. Let's say there is a number. What happens that there's a number 432. We want to print the first number, so the number of digits. So what we do, those who have some, like, it's a basic simple maths only. So the first step is what we do. We divide the number by 10. Divide number. So we have to get the unit digit first. So what we will do to get the unit digit, we will divide 432 by 10. Okay, and the remainder that we get is our first digit. Okay, so for example, let's say we have 432, I divide it by 10. Okay, so if I divide it by 10, my remainder is equal to 2 and my quotient is equal to 43. Okay, now I will use this quotient as number again. Okay, and now I will divide this by 10. Now if I divide quotient by 10, so I do 43 by 10, I get 4 as quotient and I get 3 as remainder. Okay, so the first digit was 2, second digit was 3. Okay, and my quotient now, because the quotient is in one digit, so it becomes 4, and we just do a count of it. So it means there are 3 digits. So this is the logical intuition of this particular question. Let me repeat this once again. So let us understand the concept once again. Because I know a lot of you might not have that experience in maths. So, but let me explain you. For example, let's say there is a number 568. Okay, so this is called a unit place. This is called tens place, and this is called hundred place. So in reality, how a computer writes the number, how we know that okay, 568 means 568, but how computer understands it? It understands the language of unit, tens, and hundred. So what it does, that it takes the unit digit 8, multiply it by 1, plus it will take tens digit, multiply it by 10, plus it will take 100 digit, that is 5, and multiply it by 100, and it will add them. This is equal to 8 plus 60 plus 500, and this is equal to 568. So that is how a computer thinks. So now we have to use this concept only, because eventually we are writing a program. So when there is a number like 568, what you do, you count how many unit digit, you have to eventually count how many unit digit how many unit digit it has, right? Unit digit it has. So if you progress from here to there, of course it has one unit digit only. So what we will do actually, for example, we take the number, we divide this by 10. So we take the, let's say this is n, this is quotient, and this is remainder. So what we do, initially we have the number 568. Okay, we don't have any quotient, we don't have any remainder. Now we divide this by 10. So number remains 568. So the quotient becomes 56 and remainder becomes 8. And what we do, we update this number to 56 now. Okay. Now, let's say divide again it by 10. So we get a quotient of 5 and we get a remainder of 6. And we update our number n as 5. We again divide it by 10. Now the quotient becomes 0 and remainder becomes 5. And we see the number becomes 0. So what are we seeing here? What is the, can you observe a pattern that we are trying to do? What we are trying to do, we take the number, first step is divide by 10, take the quotient and remainder. Second step is divide by 10, take the quotient and remainder, and so on. Keep on doing. For example, let us say there is also a number, let's take a 4-digit number, 2340. Okay, so when we divide it by 10, my quotient becomes 234 and my remainder becomes 0. Second, again I divide by 10, my quotient becomes 23, my remainder becomes 0. Then I divide by 10, my quotient becomes 2, my remainder becomes 3. Sorry, here it's 4, not, I'm sorry, yeah. Now again divide by 10, my quotient becomes 0, my remainder becomes 2. So what are we, I'm dividing this particular n by 10 till it becomes 0. Of course, it is not going to go below 0. And we count the number of steps. So step 1, step 2, step 3, step 4. So how many times did I divide this number by 10? Here I divided it by 3 times. 1, 2, 3. And therefore number of digits were 3. Right? So let me explain through one last example so that it is totally grained in your mind. For let's say there is a 7-digit number. 7, 6, 5, 4, 3, 2, 1. We want to count. Tell me the number of digit. So what will computer do is, first of all, you take the your starting number is this, you quotient and remainder. So step 1, you divide by 10, your quotient becomes 7. So you're starting with 7, 6, 5, 4, 3, 2, 1. Okay, this is your quotient. Initially you have nothing. This is step 0. Now at step 1, you divide by 10. You get 7, 6, 5, 4, 3, 2. And you get remainder as 1. Step 2 is divide again by 10. You get 7, 6, 5, 4, 3. And your remainder becomes 2. And step 3 is you get 7, 6, 5, 4. And quotient becomes, sorry, remainder becomes 3. Now step 4, it becomes 765 till it becomes 4. Now step 5 is 76 and it becomes 5. Step 6 is 7, 6, and last step 7 is, so step 7 is quotient becomes 0 and remainder becomes 7. So what did we do here? We kept on dividing it by 10, the number, till the quotient becomes 0, right? And how many steps? So step 1, step 2, step 3, 4, 5, 6, 7. So there were n equal to 7 digit this number has. This is how a computer thinks. Okay, so we'll try to put this thing only in our coding. So let's go to the coding part. So let's say our number is, for example, 7654321. Okay, number can be anything. We don't need to worry about that. Doesn't matter whatever we provide. So this is the number. Now what we need to do is we need to think of, remember in while loop we have to initialize something. We have to while condition. You have to think of while condition, and then we have to think about coding block. So what will be my coding block? So we focus on these 3 things. Now let's come back here. So what are we doing here? We are starting with a number. We're doing 2 things. So we are counting 2 things. If you notice here, we are counting a quotient and we are keeping a track of count. So what are we doing? The quotient is changing constantly. This is changing. It started from, for example, 568, and that time my count was 0. My quotient came down to 56. My count became 1. My quotient came down to 5. my count became 2. My quotient came down to 0, my count became 3. So technically I am playing with two variables here. One is quotient and second is count. So these both I need to initialize somewhere. Correct? So that's what I will input here. That first of all, let's say the user has entered n. Now this becomes my quotient technically, if I see. So this becomes my quotient is equal to n. Okay. Now if I print QUO, I get. Okay. So this is a initialization that I did. Okay. So the first initialization that I did was QUO equal to n. Now second initialization that I need to think is count. What is happening every time I am dividing by 10, I am incrementing the count by 1. So count is starting from 0 and it is going to 1, 2 and 3. So this is what we need to do. So count, let's say count is equal to 0 initially. Okay. Now let's write down the while loop. So now tell me, till what time are we executing the code? We are executing the code till quotient becomes 0. Right? Or we can write down while QUO is greater than 0. We have to run this code. Right? So this is the reason we are doing while QUO is greater than 0, because once it is 0, we stop our process. Okay. So now what are we doing? Is that we are taking a quotient. So we are taking QUO. We are updating it every time we are dividing it by number 10, right? So what are we doing? We take QUO is equal to QUO by 10. So 10 means quotient. For example, let's say 56 by 10. So the quotient is 5. So this double slash is used for quotient. So I did this part first. And every time I divide by 10, I have to increment my count by 1. So count is equal to count plus 1. You can also write it down like count plus equal to 1. Both are same. So it depends upon your choice. So just understand what we did here. We first of all, we took the quotient. Initially quotient was number only. We took the quotient out of it dividing 10. And every time we do this, we increase our count by 1. Okay. So this was our coding block, I will say. And now if I print, so that's all I need to do. Now if I print count, let's see what comes. 7, correct? Because it is every time it is looping around. Now remember the f string literal that I spoke about. So we can do something like that here. F, the number of digits. So this is the constant part. Digits in. So now we have to pass the number in n. So that's why in n is, and we pass it as count. So now if we sorry, I didn't close it. So yeah. So the number of digits in this is 7. Now let's change the number. So let's change the number to 456. So my code will automatically generate number of digits in 456 is 3. So this is the architecture of this particular code, that how are we using while loop to create this particular number. Now you can change it to anything. Let's suppose you 10000000. You put any number and it will give you 38. So that's how the coding part is done. How do you get the number of digits in any number using while loop? Okay, so now let's solve another question of similar type. The next question is, given a number n, find sum of its digit. In previous question, we found out the number of digit. Today we need to find out the sum of its digit. Okay. So this is the question. Now we have to build this using while loop only. So again, let's remember what we did there. We had a number n, we had a quotient, and we had a remainder r. every time we divide the number by 10. So for example, let us say the number is let's say the number is 862. Okay, so initially when I so let's say this is my step 0. My quotient is 0, my remainder is 0. Now let's say my step 1, I divide by 10, so my quotient becomes 86, my remainder becomes 0, and my number, I update the number to 86. Now second, let's say I again divide by, in the step 2 I divide again by 10, so my number quotient becomes 8, remainder becomes 6, and my n becomes 8. I update it. And the third step, what I do, my quotient becomes 0, remainder becomes 8, and my number becomes 0. So in the previous question, what we were doing, we were just counting how many steps are there. So step 1, so 1, 2 and 3. So we counted how many times we did this, 1, 2. So how many times did we update our quotient, and those were the number of digits. Now similarly, the number we have to find the sum of its digits. So sum of digit, what it will be for 862, it is 8 plus 6 plus 2. What is that? So here what we do, we start with 0, we sum. Every time we divide by 10, we add something. Okay. Now again we divide, again we add. So we create a cumulative sum. For example, let's say we create a cumulative sum. So that sum is initially 0. At the step 1, that sum becomes 2. At step 2, the step becomes 2 plus 6, that is equal to 8. And at step 3, that becomes 8 plus 8, that is equal to 16. So that is the concept of finding the sum of a digit. It is a pretty easy question. I mean, just like the previous one. In previously, we were checking the count, that how many times number is getting changed. Here, at every time we divide by 10, we are adding some number to cumulative. So let me just repeat this concept once again. Let's take another example. So let us say this is a number 8, 4, 3, 5, 7. Okay. So what is my step? So this is my step 0 initially. So at my step 1, this is my number, this is my quotient, this is my remainder. Now I need to find a cumulative. Today I need to find the sum of the digits. Okay. So my number is initially 8, 4, 3, 5, 7. Now when I divide it by 10, my quotient becomes 8, 4, 3, 5. My remainder becomes 7, and my cumulative sum, it was 0 initially, it becomes 7, and my number gets updated to 8435. Okay. In step 2, again my number becomes 843 quotient, and my remainder becomes 5, and my sum becomes 7 plus 5, that is 12, and it becomes 43. Now step 3 is again 84, 3 and 15, and we update it to 84. Now we again divide it by 4, so 10, so it becomes 8, it becomes 4, it becomes 19, and it becomes 8 again. Now I divide at step 5 divided by 10, this becomes 0, this becomes 0, this becomes 8, and this becomes 27, and this is the final number that we want, 27. See, 8 plus 4, 12, 12 plus 3, 15, 15 plus 5, 20, 20, 27 is the sum. So what all we did, every time we divide by 10, we add the remainder to cumulative sum. That's what we are doing. And previously we were counting the quotient. In this question we are adding the remainder. So let's go back to the question once again. So let's remove this. Let's say the number is 8653. Let's say the number is like this only. Okay. So what we do, first we have to think initialization in while loop, initialize, then while condition, and third is coding block. So initialization, if we see, we are playing with two variables. One, my number is constantly getting changed, right? Because I'm starting with 84357, then it becomes this, then it becomes this, then it becomes this. It keeps on changing. And similarly, my sum, it starts with 0, it keeps on adding. So these are the two variables which are varying throughout the thing. So what I will do, So first of all, my num is this. I will create a let's say sum, which I need to eventually calculate. Initially the sum's value is 0, and I create let's say remainder, let's say I create num2, okay, and we name it equal to num. So let me just print sum and print num. Let's see what are they set at initially. So okay, the numbers are set with me. Now I'll go with the while condition. So what will be the while condition here? Remember, here we are iterating till my quotient or number becomes 0. So it is the same as in previous question. We'll do while num2 is greater than 0. Okay. So what I'm doing, I'm taking the remainder and I'm adding it to the cumulative sum. So I will need to create a remainder variable. So let's say a remainder variable is equal to num2 percentage 10. So let me show you how remainder works. 56, if I do percentage, it will give me 6 because 6 is the remainder. So I'm taking a remainder, that is num2 divided by 10. For example, 4, remainder will be 4. So when the remainder is 4, what I need to do is I need to add this remainder to sum. So sum will become equal to sum plus REM. Exactly. And this is the coding part that we did. And once it is completed, let me print sum. So this is just a second, maybe I missed something. So digits is equal to number is equal to, okay, yeah, I need to update the num2 as well. So remainder is this, and I need to update num2 will become num2 by 10, because we are taking the remainder as well, but we are also taking the quotient, right? So that we need to take out. And once, so let's come back to this code here. So for example, let us say we have n is equal to 854. Let's say we have some number like this, and we want to find the sum. So what is our general architecture of writing a while loop? What we do is that first of all, we have to initialize. Okay, initialize. Then we need to write the while condition, and then we need to write the code block. So let's do one thing. Let's find what do we need to initialize. Let's come back to this particular case. If we see that what is happening here, we are every time we multiply n by 10. So this is varying from 84357 to 8435, then 843, and so on. Like it is come 8435, then 843, then 848, right? So this n is varying. The number keeps on changing, just like we did in the previous question. And this sum is also varying because remainder is varying. Initially sum was 0, and with every step my sum is increasing from 0 to 7 to 12 to 15 to 19. So my n is changing from 84357 to 0, and my sum is varying from 0 to a particular number. So these two numbers are my initializers, so or iterators. So what I will say that, okay, let's do num2 is equal to num, and sum, which will be my initial eventual sum, which I'll be calculating, that let that be equal to 0. Now come to the while condition. While condition is simple. We are iterating till my number becomes 0, till my number becomes 843 from this number to 0, right? Till that time we are executing the code. So what we are doing here is while condition. We do while num2. Why am I not doing num? Because I'm keeping n same. So let's say I'm keeping n same. I've created an instance, another object, that is num2, and I'm playing with it. So that's why while num2 is greater than 0. Okay. Now, so I hope this is clear that why are we doing num2 greater than 0, because n we want to keep constant and we don't want to play around with it, and that's why we are doing. Now first step is to get a remainder. So what will the remainder? Remainder will be equal to num2 by percentage 10. What does percentage give? It gives the remainder. For example, let's say we have 560, this divided by if I do percentage of 10, it will give me 4 because remainder is 4. If I do it 100, it will give me 34. So like this particular thing will give me. So we have got remainder equal to num2 by so now we have got remainder. So what we'll do sum is equal to sum plus remainder. So this we have got. Now that we have got so what we did till now, just let me refresh this code screen. So in the code, what I did, I took num2. Okay, first I took remainder. So I took the remainder, I divided it by 10 and I took the remainder. Okay, after that, the moment I took the remainder, I added it to the sum. Sum is equal to sum plus r. Okay, the third step will be what? Now my num2, because let's say initially it was 84357. So now I have got 84357 as my quotient and 7 as remainder. So this will become my next number, right? On which I will divide by 10. So I need to update num2 as well. So I need to write down that num2 is equal to num2 divided by 10, and then it will again pass to the here. So what we will do eventually, so we will do num2 is equal to num2 divided by 10, and once this is done, I will just simply print sum. So I got 49. So this is how this particular code worked as well. That we took a number, initialized something, then we created these while condition and the code block, and then we reiterated. So I hope this explanation is clear to you guys. We will be solving. Just try to understand the intuition, because understanding the maths behind how is it happening, that is more important. That why am I not keeping? For example, let's say in this particular case, if I add this sum above this, my code will throw an error, or it might not work. Okay, for here it is working, but let's say I do here, let's say I put num2 above this. So let's say I do something like this, and now I remove this. So my sum will change, right? Because the order of execution matters. What is my quotient at a particular loop? So create a table like the one I created for each level. For each step, create a table S1, S2, S3, and check what will be my quotient, what will be my remainder, what will be my sum, right? And when you understand this particular table in your mindset, then only you should be able, then only you should start coding. Okay, so creating this architecture in mind is very important, because once we solve DSA problems, this architecture is everything, how you actually end up coding. Coding part is simple. We have only 4 lines of code, right? It is simple, but understanding how that code is working is very important. So creating that architecture blueprint in mind is something called coding. So I hope you understood this video. If you don't understand, please comment below or reach out to me, and we'll be solving more questions on this in future videos. So we have just completed 2 questions. We will bring out 3 more questions in videos like this. Apart from this, we will also provide you other questions as well. So my target is to solve around 50 loop questions this week. So let's do that. And thanks for watching the video. Please stay tuned, and we'll be back soon.